Hi, I'm Justin from the support training team, and today I'll be giving you an overview of the main topics of Active Directory. While there are many components to Active Directory, and the limit to configuration is almost endless, we'll be covering the fundamentals that you'll need to understand and troubleshoot Sophos products. I'll go over Active Directory roles, physical and logical components of Active Directory, lightweight directory access protocol or LDAP, authentication methods such as LDAP, Kerberos, NTLM, Radius, and Azure AD. Some of the Active Directory roles that work alongside Sophos product features are AD Domain Services or ADDS, AD Lightweight Directory Services or ADLDS, and AD Federation Services, also known as ADFS. I'll go through each one. Active Directory Domain Services is a role that can be installed on a Windows server. It's the core of Active Directory. Any server with ADDS installed is known as the Domain Controller or DC. It's both the directory information source and the service that makes the information available and usable. ADDS stores and manages information about the network resources such as users, computers, and policies. It also provides support for directory-enabled applications like Microsoft Exchange Server and allows for centralized management. Active Directory Lightweight Directory Services is a hierarchical file-based directory store. ADLDS and ADDS has some similarities, but ADLDS does not allow for management of devices or users. It's strictly used as a directory store and can also host data from multiple domains, including workgroups. The Sophos Active Directory Sync tool works with ADLDS or ADDS to sync users, computers, and groups into Sophos Central. This allows for ease of management as policies can be applied to users, user groups, computers, and computer groups similar to how policies would be applied in Active Directory. Active Directory Federation Services allow you to use AD credentials with other systems or applications, such as Sophos Central. Next, we'll discuss the components of Active Directory. AD has physical and logical components. The physical components consist of systems and services that host the logical structure. This is a key concept that will allow you to better understand the way the information is organized in Active Directory. Meanwhile, the logical structure includes elements like forests, trees, domains, and more, which we'll discuss later. As mentioned before, a domain controller is a Windows server where the Active Directory Domain Services role is installed. Sometimes the term Active Directory, or AD, and Domain Controller are used interchangeably. DCs provide authentication and authorization services. The first time a domain user logs into a domain-joined computer, the computer communicates with a DC to authenticate the user. The DC verifies that the user exists and grants access to resources such as map drives or network shares. DCs replicate their data to other DCs so that the same information can be referenced from anywhere across the domain. This ensures the same level of access is retained per user regardless of what system they use, whether it be on-site or remote. A read-only domain controller, or RODC, functions very similarly to a DC. It replicates its data with other domain controllers and can be used for authentication and authorization. However, data cannot be modified directly on the RODC. This provides redundancy and availability in Active Directory without adding a potential security risk to the network, should the server be compromised. Sites are a way to group domain controllers and collections of users, groups, and computers as defined by their physical locations. This can be useful in planning administrative tasks such as replication of Active Directory. Next, we'll cover some of the logical components of Active Directory. The schema defines the rules for the objects and attributes that can be stored in Active Directory. It's a blueprint for the structure of the AD database that defines the types of objects that can be created and the attributes that can be tied to them. AD objects are instances of object classes defined in the schema. Some examples of object classes are group, computer, organizational unit, and contact. We'll cover these in depth later. Each object class has a set of mandatory and optional attributes that describe the object's properties. For example, a user object in Active Directory has attributes such as first name, last name, logon name, and email address. AD attributes are defined in the schema and used to store information about objects. Each attribute has a specific data type and syntax, which determines how the value can be entered and validated. Some examples of attributes are CN, common name, user principal name, distinguished name, and display name. A domain is a partition in an Active Directory forest. This acts as an authentication and authorization boundary, which can be used to limit the scope of access to resources. Domains are grouped in a tree-like structure and contain collections of organizational units, users, computers, and groups. Domains allow for network-wide user identity. After a user is created, it can be referenced on any computer linked in the forest, allowing that user to log into any of those computers with their credentials. Let's start by creating our own domain. I'll be using the domain sophos.com. For logical management, I'll add a few subdomains to be managed by region. I'll create a subdomain for North America and Europe. We'll also have a separate branch in Europe for our France department. These subdomains will delegate administrative permissions. Administrators in each subdomain will only have control over the objects which reside within and under them. So for example, admins in na.sophos.com will be able to administer objects within that subdomain, but not eu.sophos.com. Likewise, admins in the Europe subdomain can act only within the Europe subdomain, which also includes the France branch. Nested within a domain are organizational units, or OUs. These are used to create both hierarchical and/or logical representations of a company. OUs can also be used to delegate administrative rights and are a subdivision within Active Directory to place users, groups, computers, and other OUs. These can be used to mirror your organization's functional or business structure. Expanding out from an OU and domain are domain trees. The hierarchy shown here is known as a domain tree. All domains within a tree share a contiguous namespace. In our case, it's sophos.com. It's also possible to create new top-level domains. I'll add sophos.training to our forest. Some companies choose to create new top-level domains to distinguish different areas of activity within the organization. With this addition, we now have 2 trees in the forest. Further expanding out are forests. Trees within the forest are joined by trust relationships. This means that a user located in sophos.training can also be given permissions to access resources in the sophos.com domain. For more information about domains and trees, refer to the documentation in the video description. Lastly, there are multi-forests. A multi-forest is a connection of different forests added together, forming a forest trust. Companies may have multiple forests if there are isolation requirements or if they recently acquired another company and are planning to consolidate the structure. You can read more about this and how the global catalog service in a domain controller makes this possible by referring to the documentation in the video description. Now let's move on to the Lightweight Directory Access Protocol. LDAP is an open, vendor-neutral, industry-standard application protocol which provides multi-platform directory services. Active Directory is built on LDAP, but is expanded to provide additional functions. With the Sophos AD Sync tool, you'll find the default LDAP query, which collects data from an AD environment to be synchronized with Sophos Central. The query can be modified to filter users based on different attributes. LDAP allows for read-write interactive access as well as browse and search functions through the directory structure. The default ports for LDAP users are TCP UDP port 389 for unencrypted communication and TCP port 636 for encrypted communication, or LDAP-S. When using an LDAP query, the directory has a tree-like structure. Within this structure, each entry is known as an object. There are 2 types of objects: container objects and leaf objects. Container objects are AD objects that contain other AD objects within them. Organizational units and groups are an example of this. Leaf objects are AD objects that cannot contain other objects within them. Computers, users, and printers are all examples of leaf objects. Here we have an example of a directory structure. Let's say we want to query for all users in an OU named support. Our LDAP query will be structured like this. DC represents the domain component, the domain in which the object resides. OU represents the organizational unit in which the user resides. If we want to query for a list of users, we can use the object class filter with the users argument so that the query only returns user objects. We can also use the CN filter, which stands for common name, to find the user that we know the exact name of. These attributes are used to identify specific information within directory objects. A common mistake when querying within the default user container is using OU instead of CN for the object class. In this case, an example query should look like this. Now let's move on to authentication. There are several authentication methods built upon Active Directory that are also supported by Sophos products. The ones we'll be covering are LDAP, Kerberos, NTLM, Radius, and Azure AD. Many of these methods work with Sophos Firewall for processes like associating network traffic with user identities. On the endpoint side, federated login allows users to sign into Sophos Central using their Active Directory credentials. LDAP is one of the authentication methods that Sophos Firewall can use to associate network traffic to a specific user. On the endpoint side, LDAP is used in the Sophos AD Sync tool. It searches for and filters users via an LDAP query. Then it adds those users to Sophos Central for policy assignment and management. LDAP can provide AAA, also known as authentication, authorization, and accounting services for users. It has a set of required operations to implement its functions. The main ones are bind and search. The bind operation allows an LDAP client to establish a connection with the LDAP server, obtain access rights to the LDAP server, and check the validity of user information. The search operation constructs search conditions and obtains the directory resource information of the LDAP server. In LDAP authentication, the client completes the following. It first uses the LDAP server administrator's distinguished name, or DN, to bind with the LDAP server. After a binding is created, the client establishes a connection to the server and obtains the right to search. Then it constructs search conditions by utilizing the username found in the user's authentication information. The specified root directory of the server is searched, and the user's DN list is generated. Finally, it binds with the LDAP server by using each user DN and password. If a binding is created, the user is considered legal. Sophos Firewall supports traditional LDAP with plain text and secure LDAP, LDAP-S, where communication can be encrypted via SSL TLS over port 636 or Start TLS over the standard LDAP port 389. Now let's discuss NT-LAN Manager, or NTLM. NTLM is a suite of security protocols used to authenticate and secure communications between Windows systems in a network. It provides authentication, integrity, and confidentiality services. It also uses a challenge response mechanism for authentication. When a user attempts to access a resource on a server, the server sends a challenge to the client. The client then responds to the server with a valid hash which is derived from the user's password. If the response is valid, the user is granted access. While NTLM is still supported in many Windows environments, it's largely been replaced by Kerberos in newer versions of Windows. Kerberos is a network authentication protocol that provides a secure way for clients and servers to authenticate with each other in a network environment. It uses a token-based system where clients request a ticket from a Kerberos server, which then validates that the username and password provided by the client is correct. Once verified, the encrypted key, or token, is sent to the client, after which the client can then present the token to devices requiring it for authentication, such as the Sophos Firewall for user authentication. Now let's talk about Radius. Radius is a client-server protocol that provides a centralized authentication and authorization mechanism, which can be useful in large organizations or in situations where multiple devices need to be managed. In Radius, the client sends an authentication request to a Radius server, which then authenticates the user based on a username and password, and then returns a response to the client indicating whether the user is authorized or not. It's commonly used in networking for controlling access to network resources, such as Wi-Fi access points or VPNs. It can also provide accounting information, such as the amount of time a user spent on the network. Radius also allows third-party integrations, such as hardware authenticators. Radius accounting, on the other hand, is a process of tracking and logging usage of network resources by authenticated users. In other words, it involves the collection and storage of information about the network usage of individual users, such as the amount of data transferred, the duration of their session, and other related details. This provides valuable information to network administrators, allowing them to monitor and analyze network usage patterns, track network performance, and identify potential security issues. This information can also be used for billing and other administrative purposes. Lastly, I'll give an overview of Azure AD authentication. Azure AD allows users to sign into the web admin console of Sophos Firewall. The Azure AD integration with Sophos Firewall enables dynamic management of administrators using role and group mapping. It provides a centralized platform to securely control access to applications, data, and resources through Sophos Firewall. Role or group mapping can be used to control access and identify users signing into Sophos Firewall. In Azure, one would create an application for the firewall, create application roles or groups, and assign users to the application. When a user signs into the firewall, Azure AD sends a token containing information about that user. The firewall uses the role or group values to identify the users and authenticates only those with the application roles or groups configured for the firewall. When an Azure AD user signs out of the firewall, the authentication token isn't removed from the browser. The token remains valid for 7 days from the first sign-in. So, when a user clicks SSO to sign into the firewall again, they're automatically signed in if their token is still valid. And that completes our overview of Active Directory. I hope you found this video useful. Let us know by giving us a thumbs up on TechVids. For more in-depth information about Active Directory, make sure to check out the resources in the video description. For further assistance, view and post questions on community.sophos.com and go to techvids.sophos.com for more great videos like this one. Thanks for watching.